So now there is a new technique of solving the block diagram reduction. It's called signal flow graph. By using signal flow graph, we can also reduce the block diagram in a signal flow graph, and then we can find the transfer function using the one Mason gain formula, which you are going to understand. So, what is a signal flow graph? See, a signal flow graph is what is a signal flow graph? Signal flow graph is a diagram which represent a set of simultaneously equations, which means a diagram which convert the block diagram in the form of signals, and your blocks which are in the form of gain will be converted in the form of emittance. The method is given by SJ Mason. So the method by which we are calculating the transfer function of this block diagram is called Mason gain formula. We convert the block diagram in signal flow graph, and then we apply the Mason gain formula to find the transfer function. The signal flow graph consists different nodes, branches, loops, closed loops, and it also consists some arrows which are representing that the signal is are in which direction. So the signals are in which direction is given by is representing by the arrows. So when we reduce the block diagram, when we used to reduce the block diagram, it's become very it become a very big problem, and it's too tidy or too time consuming, which a signal flow graph reduced. By using the signal flow graph, we can reduce the time, we can reduce the paperwork which we have to do in the block diagram algebra. So now, how to represent the signal flow graph? How to convert a block diagram in a signal flow graph? See, this is a simple example of a block diagram to signal flow graph conversion. If, let's say, it's a open loop system having a forward path gain GS, output at CS, and input at RS, its signal will be converted in form of, there will be a node for it, your input, there will be a node for your output, and there will be a emittance, or we can say gain, in between them. So there is a node for RS, there is a node for CS, and the gain which is given in the block will be represented on the signal flow graph line. The block will be, or the gain of the block will be the emittance of this particular line, or you can say the value of this particular line. So this is how the signal flow graph converted. We will see some bigger application of signal flow graph, how to convert the block diagram in a signal flow graph. So basically, what will be the definition of signal flow graph? Signal flow graph is a graphical representation of the block diagram algebra. It's having some nodes, branches, loops, and emittance, which is which is representing a complete control system. Let let's come to this here. Yeah, now different terms using in signal flow graph. Different terms which we are using in signal flow graph. First is node. So what is a node? It is a point representing a variable. Let's say if input is at RS, so the input is a node, then output at CS, then CS is a output node, and there are some in between nodes, like if there are some takeoff point, there are some summing points, so they are will be representing by different nodes. So in this diagram, there is a node x1, there is a node x2, and there is a node x3. So there are three nodes. If the signal, we are considering this single flow graph, so node are three, x1, x2, and x3 are the nodes of the single flow graph. A branch is a line which is joining the two nodes, which is joining the two nodes. That, let's say, if we are joining the x1 to x2, then this will call the branch which is joining the two nodes. Then there are two specific nodes are there. One is input node where the input is applied, where is the RSD is applied. Let's see in this example. This is the input node, RS is the input node, and CS is the output node. So there are two specific node. One is input node. In this case, X1. In this case, X1 is the input node, and one is the output node. Similarly, in this case, the output node will be your output node will be X2. So you can also define that input node where is only outgoing branches are there, because from input your system control system will start, and at output node there are only incoming branches to the output node. So there are no outgoing branches from the output node. All the branches will be incoming to the your output node. And there are some mixed nodes. Mixed nodes are like, if we are considering this diagram which is given below. Here X1 is the input node, it's the starting node where all the branches are in outward direction. This is in outward direction, the arrow is in the outward direction. And this is the output node. And your X2 and X3 are the mixed node. There are some inputs, there are some outputs, so these are called mixed nodes. Okay, so one is the input node, from which your system started. One is the output node where from which we are getting the output, and the in between nodes are called mixed node. Now the transmittance. Transmittance is basically the gain in between the two nodes. It is the gain in between the two nodes, or we can say, if we compare it with the block diagram. Let's see in this block diagram. Here GS is called the forward path gain, or the gain of this block. So in the case of signal flow graph, it is called, what it is called, it is called transmittance. It will call transmittance. Let me clear all this. So in this case, T12, T23, and T34 are called transmittance. T43 is also called transmittance. We can also say, let's say, if a signal flow graph is having if a block diagram is having G1, G2, and G3 as forward blocks, and H1 as the feedback block. So these G1, G2, G3, and H1 are called transmittance of the branches. Transmittance of your branches. Then path. So these are some important terms which you have to understand. What is the path? So path is the in this simple language, we can say कि path क्या होता है. Path is basically, if you are starting from one node and you are going to some another node, then it is called the path of the system. Now there are two type of path are there. One is the forward path. Forward path is the path which is started from the input node, and terminated at the output node. The path by which you can travel from input node to the output node. मतलब if you can say in the simple language कि मैं input node पे खड़ा हूँ, मुझे output node पे जाना है, तो ऐसे मेरे पास कौन कौन से path हैं जिनसे मैं output node तक पहुंच सकता हूँ. It can be more than one. इट डजंट मीन कि ये खाली एक ही होगा. ये एक से ज्यादा भी हो सकते हैं, दो, तीन, चार, पांच, कितने भी हो सकते हैं. कई तरीके हो सकते हैं. जैसे इस ग्राफ में आप देखोगे तो इस ग्राफ में कई तरीके हो सकते हैं, ये जो आपका दिया हुआ है, जिससे मैं इनपुट से आउटपुट तक पहुंच सकता हूँ. लेट्स से बस आपको ये कंडीशन इसमें ध्यान रखनी है. तो बाय व्हेनेवर यू आर कैलकुलेटिंग ए फॉरवर्ड पाथ, देन एनी नोड शुड नॉट रिपीट इटसेल्फ. You can go from a node only once. Any node should not be repeated. So if I start from the RS, which is the input, so I go like this from G1, then G2, then G3, and I add the output. Again, if I start from this, then RS, say G5, G6, G7, G8. So there are two forward paths by which I can travel from input to the output. So one is this path, G1, G2, G3, G4, and one is this one path, G4, G6, G7, and G8. So there are two paths, P1, and now one term also came into notice, that your forward path gain. So this is the path. If I, let's say this is the node 1, this is the node 2, this will be the node 3, this will be your node 4, this will be your node 5, this is 6, 7, 8. Then the path is, one path is from 1 to 2, then 3, then 3 to 4, and 4 to 5. 4 to 5. So this is one path. Another path is 1 input, then 6, then I move to the 7, then I move to the 8, then I move to the 5. So this is the another path. So these are two paths by which I can travel from input to the output. So now a term again comes, that is forward path gain. What is the gain of that path? This is the representation of path. How we are going from one node to another node. The gain will be the multiplication of the emittance or transmittance coming in between the path. So if we are considering this path, first path, let's say it's the first path, then if we are considering this first path, then our path gain will be your 1 to 2 G1 into G2 into G3 into G4. So gain will be G1, G2, G3, V4. This is the path gain. And if we are traveling from this path from 1 to 6, 6 to 7, 7 to 8, then our path gain will be G5, G6, this G5, then G6, then G7, then G8. So this will be the path gain, second path gain. So you have to remember that while you are calculating a path, then always your path will be your forward path will be from input to output, and the arrow or arrow sign will be from in the one direction, from input to the output. You cannot go like this. Let me consider this. If you are considering this path, let I go from, again I am representing it by 1 2 3 4 5. If you say that if you want to go like 1 to 2, then 2 to 3, then you, if you want, then we can go back like this, because arrow is going back like this. Then 3 to 2, then you want again go to 2 to 3, then 3 to 4, then 4 to 5. In this case, your node 2 and node 3 are repeating itself. So if you are calculating a forward path, then there will not be any repetitive node. There will not be any repeating node. You can only go from one node to another node to another node to another node. No node should be repeated itself. So the forward path is always, it's a path which originates from the input, which terminates at the output, and it's not having any repetitive node. And the path gain of the forward path will be the multiplication of the transmittance of the forward path. If we are considering this forward path, then G1, G2, G3, G4 is the path gain of first path, and this is the path gain of second path. So this is how we calculate the forward path and the path gain. So the next is our loop gain. Loops and loop gain. So what are the loops? Loops are the path which originates from one node and terminates at the same node. As you understand by the definition of the loops, what is a loop? A loop is a basically in the normal if I say that what is the dictionary meaning of the loop, and then the loop is a closed path by which you can start from a point and you can move to that closed path, and you can come back to that same point in a closed manner. So the loop is a path that originates and terminates at the same node, and along which no other node or transmittance is more than once occur. That means, let us consider this one, this diagram. In this, there are three loops. This loop, this is a loop, this is a closed loop starting. Let's say if I can say that I am starting from, let me again give it some points. It, let's say it's node 1, this is node 2, this is node 3, then 5, then 6, 4, 5, 6, 6, and 7. This is 8. So now consider, if you start from 2, go to the 3, and you can come back with along the S2 to the reverse to the node 2, then it will giving you say single loop. It's from 2 to 3 and 3 to return back to 2. This is forming a one loop. Okay. Again, from if I go from 7 to 8, then 8 to 7 reverse, 7 to 8 and reverse to 7, then it is also forming one closed loop. This is there is one loop is this, one loop is this. These are two loops, two closed loops. There is one another loop also. This is this loop, this at node 4. This is from G4 to G4. It is also a loop, but it is a specific loop which is called self loop. So do not get confused. It's a simple loop which starts from node 4 and terminate at the node 4 itself only once. There is no another node occurring in this loop. That's why it's called self loop. So there are three different loops in this diagram. One is 2 to 3, 3 to 4, 2. Then one is 7 to 8, then 8 to 7, and one is self loop, which is starting from one node and terminating at the same node, and no another node is coming in between the path. Okay, so this is called self loop. So this is called loop, which is a closed loop. Self loop, which is a single point, single node loop, which terminates and originates and terminates on the same node, and no another node comes in the path. Now the loop gain. What is the loop gain? Now the loop gain is again, as we calculate the path gain uh, of the signal flow graph. In the same manner, we will calculate the loop gain. If we are considering this 2 to 3, 3 to 2 loop, then the loop gain will be your G2 this and your S2 this. So loop gain for loop 1, let's say it is loop 1, so loop gain for loop 1 will be G2 into S2. Again, for this loop, for 7 to 8, for this loop 7 to 8 and 8 to 7, the path gain will be this your G7 and your H7. Let me delete all this. Not delete all this. Yes. This one, the loop 3 is this one, that is G7 to, we are going this time in this direction, then there is a reverse direction, we can come back to the starting node. So G7 S7, so this will be your second loop, this will be your first loop, and there is a self loop which is from this G4, which is not at G4. G4 is at this arrow. This is at this node. This is H3 only. This is S3 only. So there is a self loop of S3 only. So this is the loop gain of the signal flow graph. So we understand then how to find the forward path, how to find the forward path, how to find the forward path gain. These are the path gain. Then how to find the closed loops. These are three closed loops are there and their gain, loop gain. ठीक है, यहाँ तक किसी को दिक्कत? फॉरवर्ड पाथ एंड देयर लूप गेन्स. किसी को यहाँ तक कोई दिक्कत इसमें कुछ समझने में कि लूप गेन और फॉरवर्ड पाथ कैसे निकालना है? गेटिंग इट? आर यू गेटिंग इट?